Hello, welcome back. In this video, we are going to learn about TCP IP Protocol Suite. So let's look at the agenda. TCP IP fundamentals would be discussed first. Then we would be learning about the various TCP IP layers. After that, we would make a comparative analysis of OSI and TCP IP. So let's learn about the TCP IP fundamentals. TCP IP is basically a communication protocol. Now, a protocol means a set of rules. This communication protocol is used for data communication through the internet. Now, this TCP IP, the name TCP IP comes from the two fundamental protocols that are used in TCP IP Protocol Suite, and this is TCP and IP. TCP is Transmission Control Protocol, and it is mostly responsible for communication IP is Internet Protocol, and it is mostly used for addressing. TCP IP is basically a conceptual model, and it has 4 abstraction layers. Now, these layers have their different functionalities, and the protocols of these layers are used for performing the related functions. TCP IP is basically a hierarchical structure. And it enables data transmission between two entities through the nodes of the network in the internet, and mainly it is responsible for packetizing, addressing, routing, transmission, and reception of data between two entities. Now let us understand the different TCP IP layers. The different TCP IP layers are the application layer. This is the topmost layer. And mainly the APIs are used here. The different application layer protocols are used where the user can directly interact with the software applications in this layer. Next is the transport layer. This transport layer basically is responsible for reliable data transfer, and this data transfer takes place end to end, or we can call it even host to host. Next comes internet layer. This is the second layer from below, and this layer is mainly responsible for inter-networking between various networking devices between two networks. Various protocols are used in the internet layer. Like IP is the most important protocol of the internet layer. And in the transport layer, the main protocol is TCP. After that, we have the network access layer. This is the lowest layer. And this layer is responsible for physical data transfer through the transmission medium. This basically takes care of the signal format, intensity, nature, etc. mainly raw bits are transferred through this layer to the transmission medium. Now let us understand in details what are the different types of protocols that are used in the application layer. In the application layer, we have HTTP. This is called Hypertext Transfer Protocol. This protocol is a connectionless text-based protocol. Text-based protocol that is mainly used for accessing web documents in the internet. Now, these web documents can be static in nature, they can be dynamic in nature, or they can even be active in nature. Next, we come to SNMP. This is known as Simple Network Management Protocol. And this protocol is used for managing and monitoring networking devices of the internet. Next, we have SMTP. This is Simple Mail Transport Protocol. This is used for email purpose. After that, we have DNS, or this is also called Domain Name Service. This is mainly used to map the IP address with the domain name. For example, if we want to access the URL google.com, then we can simply type google.com, and with the help of DNS, this typing google.com will lead us to the respective IP address that is mapped to google.com, and we do not need to remember the IP address. After that, the protocol that is used in the application layer is a telnet, or this is also called teletype network. This is mainly used to access remote host by logging in with user ID and password. After that, we have FTP, which is File Transfer Protocol. This protocol is mainly used to transfer file from one computer to the other through the nodes of the network in the internet. Next, we come to the transport layer. Transport layer has two protocols. One is known as a transmission control protocol. This is a connection-oriented protocol and mainly used for data communication between two entities, sender and the receiver. Now, this is a reliable data communication in the sense that when the sender sends a data packet, let's say D1, if the receiver receives it, it will send an acknowledgement packet back to the sender. And if the time elapses and still the receiver does not receive the packet, then it will send a negative acknowledgement or NAC. So this way, retransmission of data can take place between the sender and the receiver. Next, we have user datagram protocol. This is a connectionless protocol and also used for data communication between two entities. Now, there is no reliability of using this protocol because between the sender and the receiver, no acknowledgement is passed from the receiver upon receipt of the data packet. So this is basically unreliable in nature, but this is very fast as compared to TCP because TCP is slower than UDP. Next, let us come and see what are the different protocols used for the internet layer. Internet layer is mainly responsible for transmitting packets between multiple networks. And the first protocol that we use is the Internet Protocol. This protocol is used for packetizing. Packetizing means the total data is divided into several packets. And these packets are sent over the network. Next, addressing. Each packet from the sender to the receiver must have an IP address. Otherwise, it will be difficult for the packet to be reachable by the destination. So a packet is divided into two parts. One is the header part and the other one is the user payload part. This is also called the user data. The header part consists of the address of the source and the destination and other related fields, and the user data part consists of the payload. Now this is addressing. Next, routing of data also takes place in the internet layer using the Internet Protocol. Next, we have the Address Resolution Protocol. This protocol is used to get the physical address of the device. So in order to get the physical address of the device, the sender should send ARP request and it is then broadcast. The receiver will send the ARP reply with its physical address. This is called the Address Resolution Protocol. Next, we have ICMP. This is Internet Control Message Protocol. This protocol is mainly used to find out the fault of the datagram. Many a times, datagram is not reachable or the device is not reachable. And other times, the device is not responding. So, these problems are satisfied by ICMP. Next, we come to Network Access Layer. This Network Access Layer is the lowest layer. It takes care of the raw bit stream transmission through the physical medium. Error control and flow control functionalities are also performed at this layer. Let us now understand the differences between OSI and TCP IP. Let's look at this table. Now, we have studied OSI reference model in the previous class, and we have seen that there are 7 layers of the OSI model. Starting from the physical layer as the lowest layer, then data link layer, network layer, transport layer, session layer, presentation and application layer. We have seen here in TCP IP model there are only 4 layers. So we can see here the 7th layer, 6th layer and 5th layer are combined to form the application layer of the TCP IP model. So whatever functionalities are there for the 3 layers, the upper 3 layers of the OSI model are performed at the application layer of the TCP IP layer. The transport layer of the OSI model performs the same functionality as the transport layer of the TCP IP model. The network layer of the OSI model performs the same functionality as the internet layer of the TCP IP model. Now, this network access layer of the TCP IP model, which is the lowest layer, it is actually a combination of the lowest 2 layers of the TCP of the OSI model. That is the physical layer and the data link layer. So this network access layer basically performs the functionality of the physical layer in understanding the raw bit streams that are passed through the transmission media, and it maintains its form, intensity, etc. Mainly looks into the signaling structure of the bits. And also the data link layer performs the error checking, flow control, and this happens for the reliable data transmission from node to node. So all the functionalities of data link layer and physical layer of the OSI model are performed by the network access layer of the TCP IP model. So we can very well find out the relation between the OSI layers and the TCP IP layer. This is to be kept in mind that TCP IP conceptual model was developed prior to OSI. Here we come to the end of this lesson. In this lesson, we have learned about the TCP IP conceptual model. We have learned that TCP is divided into 4 layers. The layers are application layer, transport layer, internet layer, and the network access layer. So all these layers have their own protocols, and this is hierarchical in nature, and these protocols perform their functionalities as per the task involved in this layer. And we have also looked into the difference between OSI and TCP IP conceptual model. Thank you.